Hi everybody, I'm going to take a couple minutes to go over what we did in our Zoom class for Math 113 today. First thing I want to point out is that I am going to offer office hours tomorrow and Friday. Tomorrow 11 to 12, Friday 10 to 11. So if you have questions later tonight, I will send out a link for the office hours. It'll be different than your class link. You can jump on Zoom and ask questions any of those times. Also, you can always just email me your questions as well. Also, tomorrow on Blackboard, you'll be getting a homework assignment, which will be due Sunday. It'll be about 4 or 5 questions, nothing too long. And then a video of new material also in addition to this one. Remember that since we're not meeting 3 days a week right now, we're only meeting 2 on Zoom, just to kind of keep everyone's schedule a little simpler. That third day is going to be just video material. So watch for that tomorrow. Alright, so we're jumping right in with the questions that I left you with last time. The first one was, since we know that a yard is 3 feet, does that mean that a square yard is 3 square feet? And we thought about the fact that a square yard meant a square area that's a yard long on either side. Okay, and if we think about this side is 3 feet long, right? So each of these little areas is 1 foot. So here's 1 foot, 2 feet, 3 feet. And this one would also be split into 1 foot for each of those little areas. And if we think about extending these lengths across this yard, so each of these little squares now is 1 square foot, right? It's a foot by a foot. It's 1 square foot. So we can easily see that we need 9 of them. So 1 square yard is not 3 square feet, but it's actually 9 square feet. If you think about it, it makes sense. It's 3 feet times 3 feet. That 3 gets squared. 3 times 3 is going to give us 9. Then in class, we took it a step further. This was not a question that I'd asked you to do, to think about before Wednesday. But what if we now have a cube, okay? And the cube has dimensions of 1 yard in every single direction. So 1 yard, 1 yard, 1 yard. We want to know how many square feet is that. Well, if we think about it, again, it's 3 feet in each direction. If we want to find the volume of a cube, we're going to do length times width times height. If we do that, we would get 3 feet times 3 feet is 9 times 3 feet is 27. So we can kind of see in this little cube I have here. If we think about each of these little orange blocks being 1 square foot, so this side is 3 square feet, the same as a yard, and so is this side. Here are 9 square feet that would make that area of 1 square yard. Now, if we make a cube with all those same sides, if you think of it, it's 3 layers of that area. So 9 square feet 3 times, right? So it's going to be 27 cubic feet. So 1 cubic yard would be 27 cubic feet. So if you think about where these numbers come from, 3 squared gives us 9. 3 cubed, 3 times 3 times 3, gives us 27, right? So we're adding another dimension each time, another multiplication by that number. Then the other thing I'd asked you to do was to have a rug. We had a rectangular rug, and one direction was 4 yards long, and the other direction was 5 yards long. So we first wanted to know the area in square yards. Well, it's a rectangle, we'll just do base times height. So the area in square yards would be 20 square yards. And then we wanted to know how many square feet that would be. Okay, so a couple different ways we could do this. We know now that 1 square yard is 9 square feet. So we could take this and multiply it by 9, because every one of those square yards, we think about splitting this up into square yards. This is a square yard. We know that it's made up of 9 square feet, right? So 20 times 9 would be 180 square feet. Or the other way we could do this is we can convert these. So 4 yards is the same as 12 feet. 5 yards is the same as 15 feet. 12 times 15 is again going to be 180. Okay, so either way. So we started out with that. Okay. Let's see. So then we moved into talking about some other areas. Oops. And so we talked about how we can have an area of an unusual shape. So I started out with this sheet of paper, and it was just your normal little rectangle like this. Okay, so here's my rectangular paper, and then I just cut out this little chunk over here, and I taped it up here on top. I could have taped it anywhere. It wasn't any special place. I just taped it somewhere else. So here's my kind of unusual shape. It kind of looks like stairs or maybe like a little W. So we were talking about how if we want to find the area of a normal shape, then we have different area formulas, right? We have an area formula for a rectangle, for a triangle, for a square. We don't have an area formula for like little stairs. But what we can do is we can think about the fact that when I moved this chunk from here to here, I didn't change the area of this at all, right? I just moved things around. I didn't get rid of anything. I didn't add anything extra. So if we can move things or split things up into shapes that we do know, then that's one way that we can find the area of unusual shapes. So let's say we have a shape that looks kind of like an L. And it's going to have these measurements. So it looks like this. This is going to be 10 centimeters. This is going to be 4 centimeters, 5 centimeters, 2 centimeters. Not quite to scale maybe, but we'll go with what the dimensions are here. Okay, so again, we don't have an area formula for this L-shaped piece, but we can figure out a way that we can either move things around, or kind of cut things off to come up with some shapes where we do know how to find their area. So what I'd like you to do is pause the video for a minute, and I would like you to come up with at least one way to find the area of this, maybe even 2 or 3. I can think of 3 ways right now. And actually someone in class today thought of an extra way, so I can think of 4, including that one. So go ahead and pause the video for a minute and see if you can draw this on your paper and figure out how to find the area of that. Okay, so hopefully you took a few minutes to work on this on your own and figured out some ways to find the area here. All right, so one way we can find this is if we can take an unusual shape and cut it up into shapes that we know. Okay, with not leaving anything out, not making anything overlap, just cutting into shapes. So one way might be to cut this right here. And then we're going to have a rectangle here and a rectangle here. If we look at this rectangle, the dimensions are 2 centimeters by 5 centimeters. So this is going to have an area of 10 square centimeters. This one now has a base of 10 and a height of 4. Right? 6 was for the whole thing, but this part is 2, this part is 4. So this is going to have an area of 40 square centimeters. So altogether, my area would be 50 square centimeters. Okay, a second way we could do this. We could, instead of splitting it up like this, remember this line wasn't here, we put that in. Another way we could do it is to split it in the other direction. Again, I have 2 rectangles. This one is 5 by 6 now. That's going to be 30 square centimeters. This one is 5 by 4, right? This only goes to here, so 5 by 4 is going to be 20 square centimeters. Again, adds up to 50. Someone in class today thought of kind of doing both ways, and we could split it into 3 parts. In that case, This is back to that 5 by 2. This part right here now, this is 5. And this is that 4. So this is also going to be 20 square centimeters. Which again, those 3 parts would add up to that 50 centimeters squared. Okay? The final way that you might do it is to kind of attack it a little bit different way. So if I take out all these lines that we had drawn in here, get back to our original shape. What if we think about this kind of like my paper? What if there had been a piece here and then it got taken out? So imagine now that this were a full rectangle, okay, that it went all the way around where that dotted line is. Well, that whole rectangle would have dimensions of 6 centimeters and 10 centimeters, right? And then 6 and then 10. So the whole thing would be 60 centimeters squared. But we really don't have this part in there. So I have to take out this chunk that's missing. So I have to take out 10 square centimeters. Again, I get back to 50 square centimeters. Okay. And then the last thing we did was another kind of, finding the area of a shape that we don't have a formula for. So let's say that I am going to paint a wall, right? And if you go by paint, it tells you on the paint can how many square feet it will cover. So you don't want to have to buy more than you need. So I have this wall, and my wall has dimensions of 12 feet, so it's 12 feet wide and 8 feet tall. Okay? So I could multiply these and get 96 square feet, and that's how much I'm going to be painting. However, this wall also has a door and it has a window, and I don't want to buy paint for the door and the window. So my door is 6 feet tall and 3 feet wide. My window is 4 feet tall and 3 feet wide. I don't want to paint those. So you can go ahead and pause the video for a minute. Think about how you will figure out how much area needs to be painted. Okay, so we're back. Hopefully you took a minute to figure that out. So we are not painting over the door and the window. So the total wall would have been 96 square feet. But I'm going to take out, I'm going to subtract the 18 square feet for the door and the 12 square feet for the window. If I add these up, so I'm going to subtract both of those, it's 30. So I'm going to have 66 square feet be my area of what's still left there. Okay, I don't have a formula for an area that looks like up, over, down, around the window, right? But I could start with a rectangle and take out whatever is missing from it. All right, so as I said, there will be a new video with some new material and homework up by tomorrow. And if you have questions, stop into my office hours on Zoom or email me. All right, thank you. Bye-bye.